in part B, same direction, solve using Gaussian elimination. We've got the system 2x plus y minus 3 z equals negative 4, x minus 2y plus z equals 3, 3x minus y minus 4z equals negative 7. What's the augmented matrix? Going across row by row, what's the augmented matrix? Whoops. 2, 1, negative 3, negative 4. 1, negative 2, 1, 3. What else? There you go. Now, you got to be really careful. If you copy something down wrong, one little thing, you'll get the wrong answer. Okay, this guy, row 1, row 2, row 3. Remember what we do. This is, if you can understand this problem that I'm about to present, you're going to understand the method. Because the system, the nature of how systematic it is becomes apparent when you do it on a 3x3 system. We work column by column. We get our leading ones first and then our zeros. So let me remind you what the augmented matrix should look like. The important part of the augmented matrix should look like this. 1, 0, 1, 0 going down the first column. And then the second row, second entry is a 1. Below that's a 0. The third row, last entry, third entry is a 1. And then you've got other stuff in there, right? But they're just going to be whatever numbers they are. So it's this kind of triangular shape we need. The ones down what we would call the diagonal, the main diagonal of the matrix. If you discount the right-hand side of the vertical line, we would call that guy the diagonal, the main diagonal of the coefficient matrix. Got to be all ones. So you work column by column, get those leading ones first and the zeros below. So long story short, we need this guy to be a 1. I've given you 2 ways to get it. What's the easiest way here? Okay, switch row 1 and row 2. So let's write this down. My new row 1 star, is going to be obtained by, I'm just going to say it. I'm just going to write it. Switch the current row 1, R1, and R2. Now remember, every time I get a new leading 1, and this is just my thing, I require you to write down the matrix. It helps me check your work when you're doing this as a test problem. That's why I require it. Rewrite the matrix. So we just switch them. Okay, I'm going to make row 2, row 1. So 1, negative 2, 1, and 3. And then row 1 is going to become row 2. So 2, 1, negative 3, negative 4, 3, negative 1, negative 4, negative 7. And then R1, R2, R3. Use that leading 1, use this leading 1 to get a 0 where the 2 is, where the 3 is. Okay, let's write down what we're going to do. We're going to take, okay, so we're going to get a new row 2 star. We're going to take something times row 1 and add it to row 2 to get a 0 where that 2 is in the current row 2. So what would that something be? Negative 2, kind of like in the last problem. Okay, so let's show the work over here. What's negative 2 times the current row 1? Just double everything and take the opposite of it. What do you get? Negative 2 times every entry in the current row 1. What do you get? Negative 2, 4, negative 2, negative 6. Write down the current row 2. Don't try and do it in your head without lining it up. You'll end up making a mistake. Most people will anyway. 2, 1, negative 3, negative 4. Add them up. What do you get? By design, right? 0, 5, negative 5, negative 10. Let's label that. That's the new row 2. And let's do the new row 3 now as well. So the new row 3 then, row 3 star, what are you going to, okay, it's the same format. You're going to multiply something times row 1, but this time add it to row 3 to get a 0 where the 3 is in the current row 3. What would you multiply R1 by to do that? Really, it's just the opposite of what's there in that entry, right? The opposite of 3. See how systematic that is? Okay, so what's negative 3 times the current row 3? Just triple everything and take the opposite. What do you get? So we're going to multiply that times row 1. I was pointing at row 3, but I meant row 1. So negative 3 and triple the negative 2. Take the opposite of it. 6. Negative 3 times 1 is negative 3. And then negative 9. Add that to the current row 3. 3, negative 1, negative 4, negative 7. What does that give you? By design, you get 0, 5, negative 7, negative 16. So that's your new row 3. And that finishes off the first column, right? Because we have both our zeros underneath the leading 1 in the first column. So let's rewrite the matrix. So the matrix becomes, okay, row 1 doesn't change, does it? 1, negative 2, 1, and 3. And then row 2 becomes this guy, 0, 5, negative 10. And row 3 becomes this guy, 0, 5, negative 7, and negative 16. And then we relabel the rows, row 1, row 2, row 3. So the first column's done because you've got your leading 1 up top, zeros below. Everybody see that? Okay, now you go to the second column and you get your leading 1 first. So if you go look at kind of a generic row echelon form, so here's my generic row echelon form. I need my leading 1 first. I need a 1 right in that position, kind of in the middle of the coefficient matrix. So in that second row, second column, I need a 1 where the 5 is. What do I do? That's going to be a new row 2. Row 2 star. What am I going to do to the current row 2? I'm going to multiply by 1/5, divide by 5, same thing. Okay, now remember, when I get my leading 1, I rewrite the matrix. 1, negative 2, 1, 3. The first row hasn't changed. What happens when you divide every entry in row 2 by 5? You get 0, 1, right? Negative 1, negative 2. Does everybody see where those numbers are coming from? Okay, and then row 3 hasn't changed yet. Every time you get a new leading 1, rewrite the matrix. Every time you finish a column, rewrite the matrix. And again, that's just how I'm keeping you responsible for showing your work. Okay? Now, this is what I was talking about earlier. If you're a human, you're not going to do it this way. Because we needed a 0 right in this position eventually, right? You already had a 5 here, so if you're in a human, you're just going to subtract row 2 from row 3, and you have a 0 in this position, right? You're not allowed to do that. You're a machine. You use the leading 1 to get the 0 where that 5 is, okay? So that's what we're going to do in the next step. Always use the leading 1 to get the 0. So that's going to be a new row 3. We get a 0 where that 5 is. So new row 3 star. What am I going to do to row 2? That's the one containing the 1, the leading 1. What am I going to do to that? So, I'm going to add something times row 2 plus row 3 so that I get a 0 where that 5 is. What is that something I'm going to multiply row 2 by? Negative. It's always the opposite of the thing you're trying to get to be 0, right? That's why it's so systematic. Okay, so what is negative 5 times row 2? 0. So row 2, focus your eyes on row 2. What is that? Negative 5 times that? Negative 5, 5, positive 10. And you're thinking, gosh, this is ridiculous. That's just the opposite of what I had right here. So I'm spinning my wheels. But no, you're a machine, so you don't think that, right? At least not yet. Then when you start taking over, the machines are going to be mad, right? You've been making me do all this work for nothing. Okay. So that's R2 times negative 5, and then just line it up with R3. 0, 5, negative 7, negative 16, add them up. What do you get? 0, 0, negative 2, negative 6. Beautiful. And by the way, that finishes off the column. So we're going to rewrite the matrix. 1, negative 2, 1, 3. Row 1 and row 2 don't change. 0, 1, negative 2. The third row is what we just found, row 3. And so we call that 0, 0, negative 2, negative 6. And so that row becomes just regular row 3. And row 2 and row 1 are the same. We're almost there. We're almost in row echelon form. What do we need this negative 2 to be? 1. So what do I do? To get a new row 3 star, you take the reciprocal negative 1/2 times the current row 3. Rewrite the matrix every time you get a leading 1, and you're done with this manipulation, and you can solve the system. So you get row 1 and row 2 don't change. 1, negative 2, 1, and 3. 0, 1, negative 2. And then what do you get for the third row? 0, 0, 1, positive 3. Okay. There's no real reason to label it, but that would be row 1, row 2, row 3. Because we're in row echelon form now, right? This is row echelon form. So now, once you've done that, life is good, because solving the related system is super duper easy compared to other methods. So what's the related system? Remember, if you're not told, it's X, Y, and Z. And in this one, you were told. The original system was X, Y, and Z, so you stick with that. So what's the related system of equations to this augmented matrix? So X minus 2Y plus Z equals 3. Does everybody see where that's coming from? That's the corresponds to the first row of the augmented matrix. What's R2? Y minus Z equals negative 2. Third row? Z equals 3. Now it's bottom-up substitution, like you've already seen. So let's take the Z equals 3. Where do I put that? The second equation, so that I can solve for Y. So I'm going to move up here. That gives me Y minus 3 equals negative 2, or Y equals 1. Everybody believe that? Okay. And then what do I do with in this case, both the Z equals 3 and the 1? Plug them in, plug them in. Y is 1, and now Z is still 3. So that allows me to solve for X. So I get X minus 2 times 1 plus 3 equals 3? Or what's X minus 2 times 1 plus 3? X plus, oh, careful. What do we get over on the left side? Minus 2 plus 3 is 1 equals 3. Or X equals 2. So how do you write the answer? 2, 1, 3.